Okay, thanks for coming. My name is Eduardo Silva, a software engineer at Treasure Data, and I mostly work in the open source team, trying to fix problems with logging and trying to help with the logging tools that we have built over the years. And well, we're quite happy here because, as you may read somewhere, we are from the Fluentd team, and just today we joined to the CNCF, so it's like a great momentum for us. And thanks for coming. So I will assume that most of us, or most of you, are using some kind of logging solution, or you have some kind of deployment. Just to get an idea, how much of you are using Docker right now? OK, I will not make more questions. So like half of you is using Kubernetes, right? Awesome. OK. So we're going to go from the beginning about this session about what is logging, and then introduce to the different patterns for aggregation in the cloud and how that integrates Kubernetes, Docker, and other surprises. OK, so let's get started. Logging is something very fundamental for everybody. Logging exists because of three main principles. You need to monitor something, or you need to make some troubleshooting. Things happen, or sometimes you need to gather some statistics. Right? What's going on with an application, how it's behaving. So logging, I would say that is not longer optional. It used to be in the past, but when you need to dig in something really important, you need logging. You need to gather information from somewhere what happened, right? And not just restart an application, restart a container, and let's think that nothing happens. And now when we have the logging scenarios, logging happens at different levels. The first one is like the operating system. We need to know what's happening with the kernel. Sometimes we have some storage running in our server, but that storage needs a driver. Sometimes the driver fails, and we need to know about it. This is pretty common in enterprise production servers. Also, we have our applications units, my WordPress, my web application, my backend for any kind of things. But also, I need to monitor what's going on with that unit. And also, we have system services, like the same login services. We have mail services or any kind of third-party component that our application depends on, for example, a database. And now we're going to talk about the containers, right? I assume that most of you know what a container is, but anyways, we're going to give a quick overview about the container. A container exists just to provide isolation to a process. The minimum unit in an operating system of something running, it's called a process. But when we don't have the containers, that process is running. It has a bunch of CPU. It has a bunch of memory. But at some point, we would like to isolate that application and restrict the number of resources that that application has access to. So that is what a container is. A container is not a feature, an implementation. A container is a concept on top of C groups, control groups, and namespaces from on an operating system level. So your server is running here. You have a host operating system, and you have some user space tools that allows you to create this kind of concept of container. And of course, you create the container, and on top of that, you are deploying your application. Your application has its own dependencies, its own libraries, and of course, is fully isolated. So on one container, I can be running some application with, I don't know, OpenSSL, and maybe I'm testing a new crypto library, and I can try in the other side board SSL or something like that. It doesn't matter. The system doesn't know what's going on inside the container. It just knows about what kind of CPU is consuming, what kind of memory, and what kind of devices is trying to access. And of course, when you have containers, you have applications, you have the system, you have services units, and all of that needs logging. So what are the kind of distribution channels that we have for logging in containers? The first one, which is not legacy, but the one that always works, is the file system. Well, always when your storage is working, right? So the file system writes some data to the file system so you can trigger and review that later. Also, we have the standard input and output interfaces. I don't know if you're aware, but every time that you start a process on Linux or any kind of Unix operating system, at least you get two interfaces, the standard output and the standard error. Right? We're not going to discuss right now when you need to use each one. Right? There's a long problem with that. but they exist and they're used widely. And sometimes you want to make some logging over the network. Maybe I have some remote networking service, and I want to send my messages to that central place. So as of now, we have this kind of channels. So, OK, but when you have your container, OK, you have the channels, but also you can let your logs behave or put them in a different way. So, for example, Docker integrate which is called the logging drivers. That means you're going to spawn your own process. This application is going to do something and maybe write some logs, right? But you can tell Docker, please, you know what? I want my logs to be stored in a JSON file. You say, why? Yeah, there are people using MongoDB, right? So that is quite useful. Some people use syslog, which is pretty fine. I'm not saying that one solution is better than the other. I think that as mass solutions you have, math options is better. You have journald from systemd, and also we have something which is called Fluentd, which is a logging solution. And some time ago, we wrote the driver for Docker. So every time that you get Docker, you have the Fluentd driver on it, enabled by default. We're going to make a pause here and talk about structured logs. Every time that you get some log message, there's not an structure most of the time. For example, if you look at the Apache web server logs, you will see that you have some timing associated. There's a time, there's a time zone, IP address, and what was about the HTTP request, right? But there's a kind of a structure. But if you look at the Nginx logs, it's pretty similar, but sometimes they are not the same. And if you look at the MySQL logs, which is something totally different, there's a different structure. So how do you deal with these kind of log messages that are in a different format? So structured logs allows you to handle that. For example, when you talk about structured logs, we try to make some assumption that the logs will have some key and a value. For example, when you look at the Apache logs, you know that there's a time. The key value will be time, and the value, of course, the time times or whatever. And of course, you have two minimum keys, the time and the message. Time is something very critical because you need to know when something happens. And when you deal with structured logs, there are two main formats around. Maybe there are more, but these two are quite famous. The first one is JSON. I know that everybody knows JSON, but JSON has a really, really big problem. When you want to parse JSON, it's quite expensive because it's a string, it's not binary. You don't know when a key starts, when the key ends, so you need to read the whole message. Imagine that you have a JSON map and the message field, I don't know, imagine that it's 1,000 of characters, but you don't know that it's 1,000. So you need to go each by each one, iterating until find the last one and say, oh, this is 1,000. And that is very CPU intensive. And also there's something, a different option, which is called message pack, which is like a JSON, but in binary mode. It's a serialization format, used widely. It's a JSON-like, but it's quite better for that. Of course, you cannot read message pack if you do cat and a file, right? You're going to get some trash on the terminal. But with JSON, you can do that. So how Docker deal with this? Getting back to containers, when you write a Docker log or log message to understand that output standard error, you will get some like this is a test message. But when you're using the logging drivers, you're getting something more interesting, like this. You get a container ID, you get a container name, the source, and of course the message. So if you compare this scenario with the other, I will say that this is a little bit better because you have some metadata about where this application is running, right? It doesn't matter if it's JSON or message pack. The thing is that you have a structure, you know which kind of key you want to look up and do something with it. And now, if we start thinking about microservices, meaning how do we deploy the applications, okay? We are not going to discuss in general about microservices, but we want to focus on logging. Imagine that a monolithic application, basically you have users, the service application, and this service application is writing logs to somewhere, over a network or a file system. But when you have microservices, you have your application is split in many components, maybe 1, 2, or 3. It doesn't matter. But as you know, each of these components needs also have some logging capabilities. So here logging could be quite easy, right? You just write to somewhere. But here, you have multiple applications writing to the same unit of logging. And of course, when you want to scale that, it's a bit complex. So imagine this. When you're creating some kind of application, it generates the logs maybe in a different format. And I mean in a different format, the string is different for each application. I know if you, the developers are here are creating one application, they wrote some kind of log message, right? And maybe 2 months later, they would say, oh, I'm going to add more log messages. And maybe those messages has a different format. So how do you parse that? There's some people smiling, right? So it happens. So, and also parse the plain text file is really, really expensive. And not all containers has a permanent storage. Sometimes you can start a container, but that does not mean that you have access to the file system. So where do you write the logs? So here we introduce the concept of distributed logging. Where do we put our logs? So when we are talking about this kind of architecture, we need to stop thinking about just a file system, just a fixed storage. It's about how I'm going to deal with the different aggregation patterns, how to distribute my logs. Imagine that you have, for example, you make a web application, sorry, a mobile application. You wrote the backend. Okay, you have 100 of users. And your login system in the backend is working pretty fine. It's writing to the file system. It works. But what happens if your application goes viral? And now you have 5,000 users, or Pokemon Go. It was used like a rocket. So how do you scale the logging on that scenarios? Okay? So for that, we have different architectures. You need to define that we have collector nodes, something that collect the information or collect the information from somewhere. That information is sent to which is called an aggregator. The aggregator collects information, and its job is to distribute that information back to some destination. It could be a database, a cloud service, or anything like that. So the collector retrieves the raw logs from the file system of the network. Aggregator gets the data from multiple sources. And on the destination, it also takes care of distribute the logs, but also transform the logs to the right format that the destination is expecting. So logging is hard because there's many steps in the middle. And now there's some items to consider when we are implementing this kind of logging. The first is what kind of network traffic do we want to implement on this? How much CPU I can afford for this? And what kind of failover system high availability I'm going to implement? So depending on this, we have different aggregation patterns. Okay? We're going to focus on each one of them and see the pros and cons. So I'm not saying that each one of these will be the best case for you. Every architecture, every deployment is different because everyone has a different log formats, everyone has a different load. So I'm going to discuss which one is better. Okay, we're going to discuss the source aggregation patterns. So when the application is running, for example, on this case, without a source aggregation, we have the collectors writing directly to one aggregator, right? But with source aggregation, we put an aggregator container inside our collector, typically in a Docker container, typically inside our Kubernetes pod. Right? It's about how do you want to handle this thing. And what are the advantages of this? For example, without source aggregation, the configuration is quite simple because you are just writing to one place. But there has some problems. You cannot change the aggregator endpoint address. It will be a problem. You will have many network connections. And also you will face a high load on the aggregator. So how do you want to deal with that? With source aggregation, you have less connection. Of course, your aggregator don't have too much overhead. And of course, you have less configuration in the containers. But you need more resources because you need one aggregation container per host. Because you are adding some one layer in the middle, but there's nothing free here. You need to add some cost at some level. The thing is where. Now, when we talk about the destination, when we are sending the data back to somewhere, without destination aggregation, we have this pattern. But with destination aggregation, we can make some interesting things. Because as you know, network fails, storage fails, things happen. So at some point, you would like to implement some kind of failover mechanism in which you can say, OK, I'm going to send the data to this destination, but also I want to have this secondary destination just in case something happens. OK, without destination, you have less nodes. The configuration is simple. The disadvantage is that the storage side here affects the collector side. And you have the worst performance, of course, because you have many small writes each time. You likely would like to have some kind of buffering and a big write instead of many small writes. With the destination aggregation, of course, your collector configuration is free from storage changes. So if you change something at this side, this guy here on the top level, we don't know about it. He don't care, because it just has a failover mechanism and push the changes to here, to this aggregator. So the thing is how many nodes you have. The thing is how you want to distribute the load of the logs in different places. I was talking yesterday with a person who said, OK, I have some problems because I don't know if I should have used an aggregator here or have multiple destinations or small writes. And the simple question was, OK, do you have some network limitation? No, I don't. Do you have some CPU limitation? Yeah, I have it. I'm on Amazon. OK, so you know how to distribute the load so you don't get a more expensive bill. And to implement all these aggregation patterns, which is kind of concept, you need the right tool for this kind of solution. So this is where Fluentd joins in. Fluentd is an open source data and log collector, which was designed to achieve all these kind of aggregation patterns and adapt to your own needs. And well, it was made with high performance in mind. It's built-in reliability. It manages structured logs. It has a pluggable architecture. And oh, I did not update the slide, but it's more than 600 plugins nowadays. So how Fluentd can accomplish all of this? Talking about the architecture, here you can imagine that you are getting the data in from some kind of input. So Fluentd supports many inputs. Imagine that a log file, you can listen from TCP, or maybe you're listening from the Docker log files over the network. Once you get the data in, you need to do some parsing over that data, right? Because the data has a different format. It's not the same to listen for a JSON message that listen from a syslog message. So you need to parse that. So here's a lot of complexity. And then you would like to filter out some messages. Maybe you want all of them, or maybe you want to drop some messages. Once you finish this, internally, what Fluentd does is provide you some kind of buffering. What means buffering? That every time that I get the data in, I want to keep them in memory or either in the file system. Because before to send this information back to a destination, something could happen, OK? Destination goes down, the storage is not working, so you need this buffering capability. So if something gets wrong, you can reload this kind of chunks of data and set it again later. But before to set it, you need the output plugins. So where I'm going to send this information. So imagine that, OK, I'm sending the information to Amazon S3. Right? Amazon has their own API, their own format. But sometimes somebody tells you, no, I want to use my own Elasticsearch. And Elasticsearch has their own API, their own format. So the thing is that from the main point where you collect this information and then send information back to somewhere, you need to collect, you need to parse, you need to filter, you need to make buffering and adapt this buffer data to the destination. So now you can realize that make logging in the right way is quite complex, and it's expensive by its nature. And likely, you want to format the data out. So Fluentd has been doing this since the beginning. It was started in 2011. And now, as you know, it's quite useful. It's very used. And well, it has a lot of operability with, sorry, the English at this time is not too good. With Docker, it's main inside Kubernetes, right? Kubernetes decided that Fluentd is a really good solution for logging. And what it's doing is that, OK, if Kubernetes provided the option, if you want to push your logs to, for example, Google Cloud Services, you can use the setup for that using the Google Fluentd image, which is inside Kubernetes. Or you can deploy, I don't know, please flush the logs from the same Kubernetes system to Elasticsearch. And it set up Fluentd for you for that. And also, OpenShift is using Fluentd as their main aggregator. So as of now, you can understand that logging is quite complex, and Fluentd is everywhere right now. Most of people is happy with it. Some people have some concerns, but we can discuss about it. How this works in the Docker use case. For example, when Docker flushes out some logs, it adds a lot of metadata. For example, container ID, container name, a timestamp, and the log message. So ideally, you want your containers starting flushing the whole logs to one central Fluentd. And from this Fluentd, you can send back the information to Elasticsearch or any kind of service that you are working here. Some people use Hadoop, Elasticsearch, MySQL. There's some people using SQLite, and it works. Now, in the case of Kubernetes, they put Fluentd inside the node, right? So you have your own applications in the pod, writing their logs, and you have Fluentd consuming that data from the file system. Kubernetes has the philosophy that the whole logs need to go to storage first, and then the log collectors can read from that, which is pretty fine because it's like a safe way to work. And Fluentd in the real world, well, it's been used by Microsoft extensively, Atlassian, Gree, Nintendo, and a lot of companies. The use case of Microsoft is they have something which is called OMS. I don't know if you heard about it, like Operation Management Suite. Okay? And what they do is that they said, OK, 1 year ago, they say we need an agent on each host that is working with Microsoft services, and we need to collect the information. So what they did, they took Fluentd, they packaged Fluentd and add some really good extension for that. So Fluentd is like the official agent for Microsoft to collect data from most of Linux boxes. And of course, we at the company, we use Fluentd a lot. We use Fluentd to collect 1.8 million events per second. So you can think that that is a lot of information. Of course, it's not just one Fluentd. You know, we are scaling that. And at the company level, where we promote this project, also we are a proud member of the Linux Foundation and the CNCF. And as I said before, we got some news that the Fluentd also joined the CNCF today. So what that means for everybody who's on this audience is that Fluentd will be a better citizen inside the Kubernetes ecosystem. It will expose now different kind of interfaces for Prometheus, so they can gather some metrics and get more information about it. And this is really good for us because the community is quite big. You know? We have thousands of companies using Fluentd. We have thousands of individual users. And as you saw, we have like more than 600 plugins around. And most of them are made by individuals. And now I want to introduce something different, getting back to logging. You know? I'm going to talk a new project that just born like a year ago, which is called Fluent Bit. It's different than Fluentd. And Fluent Bit initially born, like a year ago, to solve the data collection problem, but from embedded devices. So when you have a really small device, you cannot think of have Fluentd inside it, right? Because Fluentd is made in Ruby, right? So it needs some kind of memory, some kind of CPU. And for a really, really small device, you cannot have it. So we started creating a new solution for that specific market, and open source, of course, which is called Fluent Bit, which was written in C, fully high performance, has an architecture with plugins, and also be capable to gather some metrics of the system where it's running, like CPU, memory, and networking stuff. It's fully event-driven, and also is Fluentd compatible. What that means, that for an embedded device on that moment, you can gather some metrics, you can gather some logs, and send this information back to Fluentd. And then from Fluentd, you can do whatever you want. The architecture is quite similar. I'm not going to get into much details on it, but it has like input plugins. You have the main engine, and once it gets the data in, optionally, it can do buffering. So it does buffering either in memory or in the file system. It has its own POSIX threads to handle this information. And the good thing about this is that there's no locking. At a programming level, everything is just, the engine is one thread. We have multiple workers, POSIX threads on this side, but there's no locking inside them. Everything is done through messages internally.
Do I need to start Aggregation for container in order to take advantage of this logging? My question is, let's say if I have a simple application running inside containers,
Okay.
can I enable logging? Because right now I just do Docker log myself to see the logs which my application.
Well, what you can do is to modify your application to write the logs to the standard output, like a printf, and you let Docker take that out to journald or Fluentd or whatever. That's the easiest way. So getting back to Fluent Bit, so the architecture is quite good that it does not have too much overhead. There's no locking, it uses threads, but there's not locking or there's no contention in that area. And at the implementation level, when distributing this information to some destination, we are using some coroutines. You can imagine that I'm talking about a bit about how Golang works. And I will say that Fluent Bit implement almost the same concepts that the Golang language, but in C. So it's pretty straightforward to write a plugin or some extension for it. And Fluent Bit supports many things. For example, you can send, right now it's not just for embedded devices. It's being used as a complement for Fluentd and also is collecting logs from different services. Okay, we are not yet there with a lot of extensions that Fluentd have, but we are working hard on it. So one of the destinations which is really good, for example, Elasticsearch. If you're using Elasticsearch, you can use Fluent Bit to push the logs also to Elasticsearch. Also, Fluent Bit support HTTP output endpoints. So if you have some HTTP web server, and you can listen for events, you can use Fluent Bit to distribute the logs to that place. Also, Fluent Bit was made with forward, future in mind. What that means, if I have one Fluentd to other Fluentd or Fluent Bits, they can route the messages between them. On that way, you can make some kind of failover. At Fluent Bit, it's quite fast. The last benchmark, we saw that we can send one message from one Fluent Bit to the other. We can send 500,000 messages per second in this computer. So imagine what you can do in a biggest environment using just one CPU core. And that is quite good. And getting back to the architecture, it's basically just a core engine which does initialization, it does buffering, it handles the networking stuff. It also supports TLS. So if you care about security over the network, it provides that. You have a plugins manager, so you can hook your own plugins in the input for collect data or to send the data back through output. It uses message pack internally. We just talked about that. It supports TLS and use some specific libraries like Monkey to handle the whole event loop and memory handling. Another good feature about Fluent Bit is that if you are writing in an upper level language, for example, Python or Ruby or whatever, you can take advantage of Fluent Bit in a library mode. That means that Fluent Bit is not just a service, it can behave as a library. So you can say, okay, I'm writing my application Python, I'm going to hook the Fluent Bit because I want to send the logs to Elasticsearch, but I don't want to implement the Elasticsearch handler. I can use Fluent Bit easily for that. And here we have a really small example. I don't know if you can see the screen really well. This is like the C API about how you can use Fluent Bit internally. Okay, in the first line, we just include a header. Are you familiar with software development here? Most of you? Okay. This is C, but it's pretty straightforward. Okay, in the first line, we just include the header, right? We just create a context of the library. FLB is like the prefix for Fluent Bit. Then we define an input type because Fluent Bit needs to collect data from somewhere, right? We're going to use the lib or library mode, which means that my own application is to ingest data into Fluent Bit. After that, we're going to add some metadata to this input. We're adding which is called a tag. A tag is like a special flag to each record that is coming from that input. So once I get that data inside the Fluent Bit engine, I can say, OK, all the records that had this kind of tag are going to Elasticsearch. This kind of record that has a different tag, they are going to Amazon S3. That is what tag is for. Then we need to define the outputs. Always we are using the context from the library and define an output type. On this case, we are using the standard output, and we are adding a match. So everything that matches the tag test here, that it was set before, is going to the standard output. Standard output is just for debugging, right? It's not a big deal. And you start Fluent Bit, and Fluent Bit will start in a separate thread running in background, and from your parent thread, you can take control of it. Like, for example, ingest some data. And what we add support for here is that you just add some JSON message to Fluent Bit, and it will interpret that internally and do something with it. And then you can stop it anytime. Of course, here you have your own code doing your own stuff. If you're doing some data collection from sensors, metric stuff, this is very, very useful. Maybe it's more easy for you to write to the file system, but this is mostly for developers, this area. And I want to introduce something that was done a few days ago, because I know that most of people don't like too much C language, because it's quite complex for some scenarios, but sometimes they like Go. So what we did is to add support to write Golang plugins for Fluent Bit, which is made in C, but you can write your own plugins in Go. Do we have Go developers here? Yeah. So at least we can have a few plugins in a few weeks, right? So the thing is that you can write your own plugins in Go for Fluent Bit. It's pretty functional and will upcome in the next STDOUT 10 release. And also, we need contributors for that. You know, we are pretty strong at collecting data, handling that data, optimizing the whole engine. But we need people to help to contribute with destinations. So there's a lot of people asking for a Kafka output plugin. You know, but I'm not going to write a Kafka output plugin in C. You know, it will take a lot. But there's some package ready on Golang. So if somebody want to take care about that, will be great. And how a plugin looks like. OK, first of all, a package for a Go plugin for Fluent Bit is basically a shared library. So Go, when you build the Go code, you can say, I want to have a binary that you can run. I want to have an archive file or a shared library. This works with a shared library. So basically, you import the Fluent Bit Go package. For example, this is an example for the standard output, but made in Go, right? And you define 3 callbacks. And you need to define the export, because that is something required by the Go language. First, you do the initialization, and you register the plugin, right? And then when Fluent Bit collects the data somewhere and want to send this information through the plugin, it needs to call some callback that will take care of that data. And this is a flush callback, right? At this point here, you would like to send this information or do something with it. And the information that you get here is in message pack format. There's a good handler for that on Golang, so that is pretty straightforward. And of course, you have your exit callback. I don't know if we have time. We can make a quick demo about this. Would be interested? OK. Oh, yeah, we are almost on time. So I always get lost with this. OK. So here, OK, Fluent Bit is like this. Where I am? Okay. Can you see that? Yeah? Yeah. When you run Fluent Bit, you have some options, but the most important part here are the plugins that we support. If you can see here, it means that the input plugins, we can gather metrics from the CPU, from the memory. You can read your kernel log messages directly from the kernel log buffer. You can read some files. You have an input plugin to check how healthy is a TCP service. So you can tell Fluent Bit, please ping this service every second and let us know when if it's alive or not. We have some, you can listen for messages from the serial interface, the standard input, TCP. We support MQTT, forward protocol for Fluentd. And also the outputs, most interested one, I will say that is Elasticsearch forward, that we can set the messages to a different Fluentd, an HTTP output endpoint, or Treasure Data, our cloud service for analytics. So we are going to do here pretty quickly is to just collect information from the CPU and send it to the standard output. Every 5 seconds, it's going to measure how much CPU my computer is consuming and print out some kind of JSON messages. Right? This is quite useful because you can measure how your machine is behaving. I use it a lot. I used to have many issues with one Wi-Fi driver here, and I was using this to measure at what time, at what kind of time of the day it was consuming, because it was stuck consuming memory, and that was very useful to perform some reports for the people who's developing this. Okay. If you see that, it's working. Okay. Okay. But right now, I want to show you. Here we go. The Fluent Bit Go package and the examples. Here we have some Go STDOUT plugin, pretty similar to the one that I showed in the slides. So, there we go. Of course, it's adding some message pack handler here to do something with the data in the callbacks. Here we register the plugin. Here we are handling the flush of the information. We are decoding and just doing a simple printf. So if you implement a Go plugin, of course, your own code, your own logic will be on this callback. Everybody else, you need to copy and paste. That's it. So how this is built? Look at this line. This is a way to build a Go plugin for Fluent Bit. So we are going to type make. The only issue is that when you build shared libraries with Golang, it takes a few seconds, like 10, 11. But the good thing is that it works. There you go. So if you look at here, we have the shared library, okay, which was made in Go language, and its size is a bit bigger, right? Or 13 megabytes to print to the standard output. But of course, this is the way that Golang works. You know, that is a cost, the size. But performance is not too much. So, okay, so we have the plugin, we have Fluent Bit, so we want Fluent Bit to load this plugin. As you saw before, if you look at the outputs, there's no output here. There's no Golang standard output. But we can load it with the extension module. We go, where's our shared library? Example, Fluent Bit Go. Oh, no, sorry. There we go. Oh, JSON. OK. We're going to trigger the help, and you will see that the plugin is registered here at bottom. This one. So as you realize, my intention is to motivate Golang developers to join this project and contribute with something. So we are going to collect, where I am, Fluent Bit. We are going to collect, We load the extension, we load data from the CPU, and we send out the information to the Google, so Golang standard output. So it's pretty much the same as the previous example, but here it's going to use the Golang code. Right? So it's pretty straightforward how you can extend a login solution. The same is for Fluentd. If you know Ruby, you can implement your own destinations in Ruby language, or you can do it in Go for Fluent Bit. And Fluent Bit also is joining the CNCF. When Fluentd joined the CNCF, it not joined it alone. It joined it with 35 repositories of SDKs, languages, and child projects like this one. So if you contribute to this one, you are going to contribute to something really, really big. OK, so getting back to the slides, we are almost finished, guys. So this always happens. If you quit, you had to go each one of them. Oh, it's a lot of slides. Huh? Next time will be shorter. So the roadmap for 0.10 is to write Go plugins. We are finishing the built-in HTTP monitoring. So Fluent Bit, when it starts, you can query the internals. Add some variable support, because you may like to add some host name to each record, IP address, or anything that customizable. And of course, filtering. Maybe you want to drop something. This is the last slide. There's my contact, the project's address. They're all open source. So if you want to join us, you are welcome. Thank you.